Good morning, Algebra 2. Mr. Woe here. And as usual, are you with me? All right, today is the second part of section 12-1. And what I've done on this video is taken the time and worked out some of the even problems in your homework. So this way, when you work them out, it makes a little more sense. So again, starting off with example 4. The problem is telling us they gave us the recursive rule, which is this part right here. But what we're going to do is we're going to find out what the explicit rule is. Now again, this one is really not that difficult. Remember, because it's very simple. Right off the bat, we know that in this sense, even though it says 0 here, okay, it's called when we did terms, again, this really just means that this is the first term. So the first term of our sequence is 6. All right? Now, here, this part right here, that is your common difference. In other words, it is increasing by 5. So if I start off with 6, increase it by 5, I get 11. And if I take the second term, increase it by 5, I get 16. And if I take the third term now and increase it by 5, I get 21. So from right there, we can just figure out right off the bat that the explicit rule is nothing more than, once again, this is, going back to your rules a few moments ago, okay? This is the first term of your sequence, which we found to be 6, plus d, which is your common difference, which we already know that it is plus 5. This right here becomes your explicit rule. And now this part right here, they're just telling you that we're starting off with the, what they call the 0 term or the ot term. It just means that it just simply says that the very first term of the sequence is 6. Okay? No big deal. This is the important part. Okay? Because if we let n, if you go back here, if I let n become 0 here, I'm going to get 6. If I let n become 1, I'm going to get 11. If I let n become 2, I'm going to get 16. You'll see it. All right, now the number 8 is they want you to graph the sequence. And what I did is I just treated this just like graphing a linear equation. That's all I did. Okay, so to help you guys out, remember now, we could work this one out 2 different ways, but what I did is I did it as a t-graph. They want us to start off with 0, so by letting x become, I'm just treating this like from Algebra 1 days, or yeah. So let x become 0, let x become 1, let x become 2, let x become 3. Plug that into your function, do your math, and you'll notice that each one of these terms are decreasing by a half. Plot your points. There it is. This was an example where we have a decreasing function. All right, let's go on to the next page. Number 12. Again, my printout is going to be a little bit different than yours. Somehow or another, when I printed it up, it didn't print out nicely. But here it is. Thomas is going to begin some type of an exercise routine. Again, I have to go to my main thing because I can't read that. You guys have it, I don't. Ready? Thomas begins an exercise routine for 30 minutes each day. Each week he plans to add 5 minutes per day to the length of his exercise routine. For how many minutes will he exercise each day on the 6th week? So again, it's very simple. Again, we know here is your n. So this is the first day. This will represent the first term, the second term, the third term, which also represents the first week, the second week, the third week, the fourth week, the fifth week, and sixth week. And we notice that on the first week, he's going to do 20 minutes. The second week, he's going to be doing 25 minutes. Third week, he's going to do 30 minutes. The fourth week, he's going to do 35 minutes. You see a pattern here. And you'll probably notice that each one of these times of exercise, he's increasing by 5. So this here is an arithmetic sequence because it increases by 5. So going back to your formulas, we know that the first term is 20. We know the common difference is 5. Again, we want to find a to the 6th. In other words, we want to find the 6th term. So we let the n become 6. Now again, if you want this guy right here, just as a sidebar, Otis, if I take this part, I can create another explicit rule. So a sub n equals 20 plus 5n minus 5. Just doing distributivity. Combine like terms. I would get 15 plus 5n. And that is your explicit rule. So in other words, the first day we'll get a 20. The second day we'll get 25. Third day, you should see a pattern, okay? All right, that should help you guys out a little bit. Something else I wanted to do is I worked out number 16. Again, number 16 is just a sidebar. I know it had nothing to do with your homework, but I just worked it out anyway. Determine whether or not each of the following sequences is arithmetic. So again, I have worked these guys out or let you guys know. Later on, we will be working out examples like the later sections of the chapter 12. We'll be working out some of these ones that are not arithmetic. Okay, they'll be geometric. All right, guys, I have given you plenty of information to help you out with your section 12.1. All right, I'm going to let you go. Our next videos will be section 12.2. All right, have a good day. Catch you later. Bye.